Hello everyone, welcome to the Code Magic webinar series. This is our second webinar and we always helps the community, and this is our initiative to support the community and share the knowledge with the community. So today's our webinar we are going to bring the Rauf. Let me bring on him on the stage. So I think Rauf is a famous person in Flutter community, and he is a Flutter GDE and he is from London. So welcome Rauf on
Thank
our
you,
Code
Renuka.
Magic webinar series.
Thank you, Renuka. Thank you for hosting and for making this, and for but to me, trying to make a new talk. It has been a while for me trying to create a new talk, so this was a good opportunity for me to create a new talk. And shall we get into it? I guess.
Yes, definitely. So let me add your slides and let me go,
Cool.
and you can, this is your stage and you can start. So
All right, cool. Thank you. Well, we start with something scary, I guess. I published this picture on Twitter today, earlier today, and a lot of people liked it, and they seem to realize that it resonates with a lot of people, maybe because it was scary and it reminds them of something very, very ugly and nobody wants to see in debug mode, at least, which is the red screen of death. Which brings us to this topic of today, which is a guide to Flutter error handling. And today here with me, Code Magic. So hopefully by the end of this talk, we will be able to have learned new tricks, or we managed to learn one or two tricks about how we can improve our error handling in Flutter. So let me just get into it. First thing first, this is something I'm pretty sure all of you have seen. We have a very simple UI here, and on the left side, you can see the red screen of death, but when it's upgraded and it goes into release mode and it's in the hand of users, it becomes the gray screen of death. And both of them are the same error. They are just displayed differently. And obviously, without asking you any questions, I'm pretty sure all of you are afraid of the same one. The red one is okay, fine, because it's in your hands and you actually can make some changes to fix it. And you have stack trays and all of that. But on the right side, we have the gray one, which is deadly, doesn't say anything, and it just means that nothing is being displayed to the user. So what can we do about that, and how does that happen? All of that will be discussed today. This is the problematic widget that we created that was causing the issue. As you can see in the build method, we are explicitly producing an error. We initiated an empty list, and then we tried to access the element at the index 10. Obviously, that doesn't exist, so it will throw a range error, and that range error is going to translate into the widget not being drawn, and any space or any size that widget was about to take is going to turn into this red screen of death. That's one kind of issues or errors or problems. Let's figure out the definition of these as we go, because all of them are different, and especially as we get into the code, they will be treated differently. This is another example. I have a button and I'm doing a very simple operation to fetch the data. That button is calling an API, JSON placeholder, which is very famous, just famous for trying and playing with APIs to get a list of users. We initiate the state of the UI is loading, and then we initiate the error message. And then after we get the data, we will reset it so that we don't show a loading indicator. Now, I'm not sure if you have noticed or not, but the placeholder has a missing E, so it will not be returning the data. It might also be offline. It might also not be JSON decoded properly, and any of the other reasons. The goal is something happened, something wrong outside of our control happened when we call this external service, and when that happens, the execution is going to stop at this line. It's not going to proceed to the next line. And with that, we will end up with a stuck status. So when you click on fetch data, it's going to set the initial status to loading, but then it will never recover. It will never bring it into is loading false, because that is the issue here. It stops the execution. It doesn't go to the next line after http.get. We will not be calling JSON decode. We will not be calling set state. And all of that is, in a nutshell, what an error is. So the solution is obviously a very basic try catch block. So what are we going to do is put the entire code that we think might cause something, and then we catch the error, we print it, and then we set the state into loading again. Obviously, that's going to fix the error, but this is not a user experience that you would like users to have, to say an error occurred and you print it and all. This is like the bare minimum. Work is done, error handled, yes, but that's definitely not how to do it the proper way. There is much more to it, and let's dig deep into it. So let's take a crash course. So just for everyone knows what try catch is, but let's just revisit it quickly. So we have the try bit or the try block, let's call them block, and then we have the catch and we have the finally block. This is an example of how we are going to use it, simulating a network request, because we wanted to throw an error if we want to, so that we can just make a quick test here. And then we have the catch bit where we set the error, and finally we set the state again. How do all of these work together? The first bit that will be executed is whatever is in the try block, and whenever we hit a dead point is when an error is being thrown, then we will go straight into the catch block. In this case, the simulate network request function is going to throw an error, so we don't end up calling set state data fetched successfully, but we will go into the catch block and we will say the status is error. But also finally is going to be executed as well, but it will be executed after the catch. It doesn't matter whether try has been successful, is in like no problem has happened, or it ended up causing an throwing an error and being catched here in this block. It does not matter what the situation is. Finally is always going to be executed. So it is a good way to do data cleanup or resetting the state or recovering. So that is, in a nutshell, a try catch with finally block. Catching specific exceptions. So here in that function, we did not see the implementation for it, but here we are producing multiple errors based on whatever the situation is. But let's imagine that this function is just going to produce a different kind of error based on whatever the situation is. Now, this function, when we are calling it, we will have to handle all of the exceptions that it might be producing. Obviously, we know about all of these situations. We just take a look at the code and we know that it might produce a timeout error. It might produce a network error. So we go through all of those one by one and create a try catch, but with a specific on modifier, whatever is it called in Dart. So we say on and then the runtime type for the error, and then we catch it as usual. So we, instead of just saying catch generally, we just specifically catch a specific type of error. As you can see, it looks very clean and it looks very maintainable, and we also have the finally bit after all of that, which always should be at the end. Another way of doing this is obviously using a runtime types. So we just have one big catch block where we say, hey, if E or the error exception is a timeout error, do this. If it is something else, if it is authentication error, do this. This can work. Obviously, might produce the same result, but you have to be very careful. That's why I have put them here next to each other. Is, for example, if one of these classes, the class hierarchy, is dependent. So, for example, if authentication error is also a network error, and we are doing it in an organized way, or like in a particular order, then it will say that if the error is network error, but authentication error is also a network error, then in that case we will be calling the wrong version of the state, just because the errors we are trying to figure them out based on a specific order. While on the other side, if we are using the on keyword, it does not depend on that, and it is more simpler to understand. That doesn't mean that this approach where we check for the runtime tab, which might be also a bit costly in terms of performance, but really nothing to worry about. It's literally just micro optimization if it matters. But for complicated scenarios where you need to know more about the type error, and you are not just looking for, okay, is it a timeout error and that's it, then that is when we check for the runtime type using if else, and maybe look into the details of the error as well. That's for specific issues. Now we have something called rethrowing. So why would I ever rethrow? If I get to a point where, for example, I have an API call and somehow it produces a network timeout, and then I catch it, what I will be doing is sending a different version of that, let's say called transforming that network error into a failed to load data, because that's more relevant to the user, let's say. And then we have the repository layer. We are gonna call that function, and then suddenly we get a generic error. We don't know whether it was network timeout or something else. We just know that we failed to load the data, which is relevant to repository, but doesn't make sense once we go to the UI layer, because at that point we don't want to just show a generic error message to the user, which is, oh, failed. We go back to the very first image that I was saying. We don't want to show the user your application has failed to load the data. That's the problem we are trying to avoid. So in order to avoid that or get around that, we probably should be doing custom exceptions. So we define a class for each of the exceptions that we are expecting to happen. So for example, network exception, a specific one, and then we add all the other data related to it, as much context as possible. The thing is that's different is when we produce that error, we are not gonna just throw a different one. We are just gonna rethrow it. So it resurfaces and it goes to the repository layer, and we are at the UI layer, and we still know that it was a network exception. So we can say a network message, which is it failed due to your connectivity, or it failed due to network. But we know we didn't lose the data by handling the exception and throwing a different one. That's an easy way to keep the context, or let's call it preserving the error context and type. Also, the other way rethrowing is useful is selective error handling, which is we are at that layer, let's say the repository layer. We handle such few types of errors, but then we are not going to handle a specific type of error. We want to send it to the UI bit, or send all the data into the UI layer, and that's where we will be handling it. But in terms of propagation, rethrowing is a way to ensure that we keep preserving the error and the context type as much as possible to the highest level that we need it to. But at the same time, we can handle it and probably also add more context to it. So for example, we get the technical detail, or we get the technical error from the API layer, which says this is the status code and this is the issue and all of that. But then when we are in the repository layer, if we have much more context to add, we will be able to add that in the login phase, and then rethrow the error in the end to get a feedback or try to recover from that state. That's about rethrowing. Something else is async error handling. This is very easy a problem to get into for people who probably come from other languages, but I think all of the languages now have some sort of a way to handle asynchronous error handling easily. So I'm not going to call out any other languages, but it exists out there. For example, here, load data function, we have an asynchronous function called fetch user data, and then we're going to use the then operator to get the data. And once we have that data, we're going to set the state. But we are using a try catch around this so that we say, oh, if there is an error here, catch it. And it might work in some cases, but not the asynchronous bit. For example, anything that is in the fetch user data that is synchronously done will be catched, but the synchronous bit is definitely not going to be catched, or anything in the try block that is synchronous is also going to be catched. But for asynchronous loading or anything with futures or streams, there is a special variables or special ways of handling the errors. So here we have then, which is when everything is successful, but we also have catch error when something goes wrong, and that is when we can handle it. So instead of doing a try catch, we will use catch error. But obviously the better, more robust approach is using async await wherever we can. And I don't see so many other places where using then is actually useful or much better than using async await. But async await just ensures that we will be handling the asynchronous errors just the way we handle the synchronous ones, because it will block the execution just like a synchronous function will, and it will catch it correctly. Now, can any of you guess what's wrong with this one? So I have my app and I'm running my app, which is the entry point for my app generally, and I would like to catch all the exceptions that I'm not handling. So for example, I have an exception and I'm not checking for it, or I'm catching it, or doing anything to it. So it's unhandled or uncaught exception. It propagates until we get to the run app, and then it causes something to happen. In that case, should I use try catch? Obviously, this one will work, but only in the initialization phase. If any error happens after the initialization phase, which is literally once you see the first frame, probably it's done, and you will never be able to get anything to propagate to catch. So here there is a notion of in Dart called zones, which is some sort of a way to encapsulate a region of code, and anything asynchronous that happens in that region is going to be intercepted. So we can think of this as kind of a middleware. So even the asynchronous ones, and we have passed this code. So if there was another line of code before the final bracket, that will be executed. But then let's say an error happened inside my app that was caused by something asynchronous, for example. In that case, the error is going to be caught in the zone, and we will have the exception, and we will have the stack trace. So obviously this is not this is good and this is bad. This is definitely, the try catch is not going to work, is not going to do the job, and the run zone guarded is going to do the work. This is not like comparing, oh, this is my preferred approach and this is good, because the other one doesn't work because it's only one-time execution and it misses all the asynchronous errors that might happen in your application. Now, let's take a look behind the scenes. Now we have seen, like, obviously the basics of Flutter errors. Let's see just what's happening behind the scenes. And one thing we have to make sure we are on the same page on is that not all problems are the same, and they should not be treated the same way. There are two classes in Dart that defines a problem. I said in my talk how to handle errors, but it probably would have been a better title or more abstract if I said how to handle all the problems, but that also doesn't sound as technical as I wanted it to be. So we have two different classes or items that will be thrown in Dart or in Flutter. Sorry. One of them is error and the other one is exception. We probably are mostly familiar with exceptions because we create them and we handle them all the time. And every time we probably get to see more exceptions than we get to see errors as we interact at the higher level as a Flutter developer. So an exception is not literally like an error. It's like an something to be handled. That is why it's called an exception. It is expected to be an exceptional condition and it should be handled. It's not, oh, we did not expect this. It is expected. It's the other way around. And an exception is when you are trying to decide whether I'm going to define this as an error or as an exception. An exception is something that we can recover from. There is a way, there is a path that allows the program to recover from this case. Sorry. An error is, on the other hand, is something that is pure logical mistake, something that we made an error and we need to fix. This is what should be on the board, trying to fix it, but not to handle it. Um, um, but also it can be something coming from the system, like a memory issue. For example, we run out of memory and we call this function at the wrong time. We're going to get that error and we won't be able to handle it correctly. So that's the difference between the two. They are not the same. One is recoverable, one should be expected, one is super serious and we need to find a way of fixing it. The other one is more like, this is a case to be handled, then this is a program failure and we can do nothing about it. These are some examples. Argument error, state error, you probably have seen it in Flutter. Range error is the one we have seen initially when I was showing the pictures of the Flutter app. A type error. Those are unrecoverable. Like, you just go into the code to handle them in a different way. Not as, you don't go into the catch a statement and try to handle them. On the other side, we have something like a timeout exception. So a timeout exception, you call the function and the service takes a long time and we have a timeout, then we say, hey, this timed out, try again. So there is a path to recovery, which is try again. We need to provide the user with a way of fixing this problem, or we might just, oh, okay, this happened, then we might try it different way because we know about this, we expected this to happen. And that is, in a nutshell, the difference between an exception and an error. Just quickly. Drink some water. And now let's talk about Flutter errors quickly. We have seen this, so we know what is it. This is the gray screen of death or red screen of death, based on whether you're on release mode or dev mode. But to my surprise, or to probably some of your surprises, that this screen does not have to be this way. Probably almost a large number of people actually ship their app with this. But in a production quality application, you might want to do something much better. You might want to tell the user, hey, something happened, instead of showing them a gray screen of death. You want to show them, hey, something went wrong, and these are the details. Obviously, maybe contact us or have a button to share it. We probably also have got the details about it already. But this is customizable. It is just another widget in Flutter, and we can do it globally to replace the red screen of death or the gray screen of death globally in your application to something nicer. If you are expecting to see it a lot, but you don't have a way of just fixing it all together at the same time. But it is a good thing to know. This is what Flutter provides us out of the box to handle the errors or to catch the errors. We have Flutter error on error, which is a callback that will be triggered anytime something goes wrong or an exception has been thrown, error has been thrown during Flutter build, paint, or any of the Flutter feedback callbacks. Anything that happens during that time is going to propagate and go into error. Error widget.builder, this is how we override this part of the UI here, and we just provide it with a callback that will build another widget that we will get some details about the state or the error and all of that as a message or as a string, so that we can handle it correctly. Another one, which is a new one, is the platform dispatcher. This one is going to catch every single error. So any error that can happen and when you're running your Flutter application is going to propagate and go through here. Obviously, only the unhandled errors, for example, if you did try catch and you catch a specific exception, is not going to go up unless you rethrow it again. So this is how you set up your Flutter application for the best way of tracking and knowing about all the errors. You have at the main Flutter error on error, you know all about them, and you print them to the console. That's the default behavior. But you also want to send it to a log, like login service or an error reporting service. So that's why we usually override it here at the main function level. Now, how did I change the UI for the error? Customized it. That is through the error widget builder. We can do it also through material app, but this is probably how to define something global that's going to change all over the place. And platform dispatcher, this is where anything else that was not caught by Flutter, for example, asynchronous calls, anything like, for example, native platform channel calls that did not propagate properly or did not end up going to Flutter errors by any chance, that is going to end up going into the platform dispatcher. So platform dispatcher is the kind of the, the master of getting them all. Now, what are we getting with all of these is that we get in the exception, which is we already know it because we can create it. It's a message, it has more data, but we always see in this object that comes with it, which is the stack. Obviously, a stack is a data structure, I think is LIFO, so last in, first out. That is why we see this uh, order. So when we print a stack trace, we see when the error happened and then which package it is, the function name, and also the line number where that happened. And it goes down into the stack of how this function was called from the Flutter side until we get to the main function that was called. So it's a good way to track, okay, this was caused by this because it was called from here. So stack trace is very, very helpful, and it is probably the only way for us to know when something goes wrong, where it happened and how it happened. Like stack trace is probably the most single important information we will need to debug any kind of issues. So for that, we don't want to just settle down with a basic one. So there is a stack trace package provided by the Dart team that allows us to format the stack trace to make it look nicer. Obviously, it's very subjective, but this one looks a bit more clean to me. They also have a way of chaining them so that we know the order of the asynchronous operations. So it doesn't look too much of a difference between these two. But if we are doing an asynchronous operation and something went wrong, this is the default stack trace, and this is the formatted one at the top, and this is the formatted one with the chain capture call that happened or that was part of the stack trace package. So it's a way to reformat and gather information in a more helpful way from the stack trace. It just takes the string. It does not change too much to it, but it is more helpful for debugging asynchronous calls because, as you can see here, the formatted one versus the chained one, we can see when the asynchronous cap happened, and if there is multiple ones, we can also tell that. That is the stack trace package. Now let's take a look at some best practices around handling errors. And this is just from my experience, the main error issues that happen when doing error handling. We have generic error messages that won't help users. We are showing the user, hey, something went wrong. That is definitely not helpful. It will just make them go crazy and give you 1 star and or just send you an email or whatever. So just showing generic error messages is not a good way of handling errors. Missing context in error reports, this is more like for us as developers, because we are trying to debug errors in the wild. People use the apps in different ways you never expected. So you would like to know as much details as possible. When someone says, oh, this is not working, you cannot tell whether the reason was the network, or was it the memory, or was it the file system, or was it the firewall. You need to know as much context as possible. So missing context is the second next problem. Swallowing exceptions, which is the case when just you catch an error and you don't send the information about it. The other one is login, which is definitely not print statements. Login is more about giving the context or what's happening, to give the context to the developer when they are trying the application to see the flow of information and what is going on. So you don't treat login the same way as a simple debug print statement that you do quickly to check whether this thing is working or not. And lack of centralized error management, this is something I have recently encountered, and I think I'm leaning towards a more centralized error management more and more. Obviously, you cannot have centralized for everything. Like, we cannot have one file where it's handling all the kinds of error. That's definitely not possible and definitely not advisable. But what we can do is have a way where we have a middleware that can where all the in-code exceptions or in-code errors are going to pass through it in a way that will allow us to have some sort of an easy way to know when the error happens. For example, you get a report from a user that something happened. You can go to the details, or you can go to the logs and change something in the centralized error management, and it might lead you to figure out this problem easier instead of going to all the files and trying to figure out how can I figure out whether the error is coming from here or here. So let's take a look at a simple example for each one of those cases. Obviously, the first one is the error messages. So here, fetch user profile is throwing an exception if we fail to load the user or fail to fetch the user. And what we are saying is obviously, hey, if you catch an exception, throw another one and say that an error occurred, and that is not going to help anyone, not the user, not you. So try to maximize the usage of custom exceptions or provide as much data as possible. This is your time to just take a second. Instead of rethrowing the error, instead of just looking at what you have in the next line of code, try to probably even introduce more elements to this function so that you have more context to it. So yeah, this is how we can probably provide a better user experience. And if we have centralized exception or error handling, we can say every exception we have in our application needs to have a user-friendly message. Obviously, the user-friendly message is something we write, but then we have the code and the stack trace and all of that, which is friendly to the developer. So we need a combination of both, and that is how we fix the generic error messages problem. Missing context, the way we add it is, as I just also briefly mentioned right now, is through login, for example, and through literally collecting or creating variables that are not sometimes related to this point exactly, but we have access to it. So you might say, why am I just adding a context variable? The context variable in that case is going to have any information. So for example, what was the amount and what was the card token on all of those? If I can bring them into my error report or to my logs, it will help me understand better the type of severity or the type of issue or why it happened. For example, it happens only when there is a specific amount, and that amount is over 1 million, for example. Then it gives me more context instead of just saying, hey, payment error, and this is the error, but we don't know the reason because it just always happens. But we can find patterns if we send more context. So the data is going to help us debug much better. Swallowing exception silently, as I said, you have a function and then you are annoyed by the exceptions being thrown by it, and you're like, okay, sometimes it works, sometimes it doesn't, let me just print the error and see when it happens. No rethrowing, no throw in, no return value, no nothing. That is how you swallow or you handle an error silently, and you should never have this kind of catch exception in your code. Always rethrow, always throw a new exception, or change the state or do something that is not just printing the error. This is an example of also another mechanism through union types where you can force the users or the implementers of this API. For example, if you're creating a simple repository, you're going to force all the users of your repository to handle the state when there is success and failure, which is, and how does that work is because Dart is strongly typed and we can enforce them, hey, you need to fill this part, even though you don't know about it. Sometimes if you don't do a try catch, you can easily miss it. But if you have a result and that result can have a success and a failure, you will know that there will be a case of failure and you will handle it. So this is another workaround to maybe enforce in an organization or like in a bigger company where, okay, there are a lot of calls and sometimes a small call is being missed, and we have probably a try catch that has 3 different calls, and we are handling like, for example, we have 3 different lines of code in a try catch, but all of them can fail differently, but we are just catching the exceptions of the first operation. So that's how you end up having issues. This is probably easy to miss because like can you imagine having to try a try catch for each one of them? You'll be like, okay, I can put one big try catch on all of these operations, and you easily end up in an issue status. The other approach is with this return types, which is a way for us to ensure that we will handle it. We will know based on the response, and we will always handle the failure because we are kind of enforcing it. Um, per login, per login is somehow a way of saying, yeah, just don't say print statement and say this was successful or this failed. Try to add as much context as possible, maybe even the same context that we added for the error reporting as well, if we are being lazy, but as much context as possible. Centralized error reporting, this is the final bit, but let's say create a middleware. Like, as we have already seen, we know we have the platform uh, whatever is called the platform instance in Flutter that allows us to access all the encode exceptions. That is a good place where we can create a custom callback where we will handle any kind of errors and handle them in a specific way. Those are the problems. Now the final bit is monitoring. And to this, we come to this question: what is worse than having problems in your app? What's worse than having issues and exceptions and all of that? Is literally the fact that you don't know about them. So if you send your application to the wild, you deploy to the App Store, to the Play Store, and all of that, the first thing you have to know is that your app, before you publish it, you need to have a way of error monitoring. This is just a very simple table to compare the available offering for us as Flutter developers. The most common one is Firebase Crashlytics, because Flutter is always sold with Firebase. It is very easy to very easy to set up, and also free. Um, doesn't support Flutter Web at the moment, I guess, as of the last time I have checked. But it gives us really good context because it also works with Firebase Analytics. So all the analytics that are collected by the app when we are sending analytics are also put together with the crashes, so that we have the stack trace and we have the analytics trace. So kind of two stack traces. Sentry, Instabug, and Datadog, all of them, they have their offerings. I have only used Sentry as another option. I think at this point they also have native crashes reporting. But for me, the only one I have extensively used and have most of my knowledge on is Firebase Crashlytics, and I have never had issues with it, and it just works fine. The only problem is that you have to use a Firebase project, I guess. It's not that lightweight. You need to add all of the Firebase core things in order to use it. But if you use Firebase, it's definitely a good solution to go with instead of using another offering. But if you don't use Firebase and you think adding Firebase Crashlytics is going to be costly, next one I will go with, in the sense of Flutter with the most support and the best package, is for me Sentry. One more thing is, when we build for production, we are not just going to call Flutter build iOS. We're going to need to obfuscate the code, and that means a lot of the things that are in our code, let's say variable names, strings, and all of that, they will not have the same values in the binary. So someone was trying to, let's say, deassemble our application and find specific, for example, he's going to look for API key in the strings. We won't like to change the value, the variable number, the variable name to something else, like so much more random, or a number, or anything that will not be API key number. But for us, we need that value. We're not going to obfuscate it because we still want to read it. The problem that comes with that is, once you obfuscate it, you will not be able to, the app, when you get reports, for example, in Crashlytics, you will not be able to know what kind of error is it, because it will give you this error. It will say your app has one unprocessed crash, which means that you have a crash. We know that a crash happened, but we cannot show you anything because everything is obfuscated. And for that, what we will need to do is desync files, which is symbols. You can imagine the symbols file as a table that maps every single one of those random cryptic words into something that makes sense, that is the same variable name that we had. So if the obfuscated one is B7A, the value is API key, then that table is going to needs to be uploaded. So that is in the simplest form for it. This is what you need to set up before sending your app to the App Store. For first of all, this can be automated. Here it's just giving us an option to do it by uploading the file through like manually, but the option that we should be using is script. I have tried this yesterday, just tried to create a very simple application where I can crash it and get the errors to ensure that I'm giving you up-to-date informations, as well as making sure that nothing has changed and the documentation is up to date. But let me know if you have questions specifically about this bit, because I have spent probably almost last night trying to get it to work, at least on iOS. I don't think I will be going out of time, so I will finish here. And if we have any questions, that will be a good section to go to next. Thank you all.
Sorry. Amazing session, Raf. This is a
Thank
really important topic. People, when you develop any application and when you are getting some errors, then you can just scratching your head. Oh, what is happening here? How to solve that? And but getting a log of that and reading the log and solving the error. This is the big thing, right? And if you handle it properly, then you save a lot of time, basically.
I
And
mean, if you don't handle it, I mean, the best thing they say is that if you don't know about the issues, they don't exist, but they exist. So you better handle them.
yeah, like a one of the time, uh, I have seen that when we developed some application for the GDG London as well, and things like the app works properly in debug mode, and we just put it in the production, and we can't see anything in error something, and then suddenly our some pages are not able to display on the app.
Oh.
And yeah, so such kind of error happened. So what kind of precaution everyone should take, that if something is not showing in debug mode, but it is in when you put it the app in the release mode, then how to handle this kind of errors, basically. So
Yeah, I mean, basically, the main precautions is obviously before you send anything to the App Store is you set up a like crash reporting and ensure its work. Like literally before even having an icon for your application, have Crashlytics or Sentry or Instabug on all of them working, and you basically just give it a simple one or two errors, and you click on the buttons, and you try to generate, like for example today we have discussed all the kinds of error that are possible, so you just try to make sure that all of those errors are being caught. Once you're done with that, you're going to have to forget about it, and all the issues are going to start coming to you easily. So that is the first thing to do as a precaution. But the difference between debug mode and release mode, we have seen one, for example, which is obviously how uh, we have seen the example where it doesn't. First one is that it doesn't look exactly the same. I mean, I'm trying to think of sometimes where I had actually. It's usually always native errors that happen, but not Flutter specific.
yeah.
Um, but what would be a good way to ensure that we can safely be safe? I don't think there is a complete safety, and to be honest, we'll always have one or two things we will be learning about in the future, and we don't know about them yet. But as a good example, I think I have seen this weird case with Firebase. Sometimes it handles differently from Android to iOS, which is obviously something that also can relate to uh, like even if you're on iOS debug versus release mode, it doesn't work. This is just because of platform differences and how it was compiled and all of that. Um, I mean, the only way I knew about the issue is because I had crash reporting set up, and this issue was happening only on Android. So that was one thing. There will be many issues that probably can happen uh, only in debug mode. I think debug mode will have probably more issues than in release mode. So I would say the final testing to assure that this build is good to go is through iOS or
Okay.
is through release mode. I'm not sure if I'm making too much sense, but my whole idea is um, instead of trying to assume that, okay, if it's working on debug mode, I will assume it's going to work on Android. What my idea is, if it's looking good in debug mode, just be happy, but don't say it's good. Like, you need to go back or the other way around. Like,
Yeah.
for example, in my company currently, every time we do a release, it does not matter how simple the change was. The only way we say it's good to go is through looking at the release mode. So I don't think we can, or maybe there are other ways of ensuring that, but in my
Yeah.
perspective, ensuring that or testing that release mode app and making sure it works is the safest bet.
And one more question here, because it's Flutter, it's a cross-platform application. You can develop the app for the many platforms. So how you can manage to the different platform errors? Basically, if my application is served for the web, then iOS, Android, then let's say it's for the watch or any other platform. So is there any specific thing we have to do it for that? Since
Well, that's the thing. All of them are different platforms, but we are always in the end going to have to propagate that through a Dart method. So we are not going to call the native method right away. We're going to call it through a platform channel or an FFI method. And with those, they have a very specific protocol. For example, on iOS, you will have to throw an error probably with every result. So every result needs to also have like a good state and a bad state. It does not matter what kind of method it is. It's like a Swift protocol that ensures that. On Android, I think it comes down to the how generous the native developer with the library is going to be. But whatever is going to be sent is going to be sent as a string that the package developer. So this is more like the responsibility of the package developer. But obviously, we can use platform channels without being package developers. In that sense, we'll have to use the already ready protocol for us, which is to transform any kind of native error. I think there is a page in the Flutter documentation that says this kind of error is going to map to this, but usually it's based on a string. This is the string, then we're going to take as much information from that string as possible, and then we transform it into a Dart one. Sadly, we do not get the stack trace from the native side. We only get the stack trace from the Dart side. So we have only the strings, and we can deal with as much, we can try to gather as much data from those strings as possible. Trying to think if there is any other scenario where multi-platform is going to be problematic. I think also there is Pigeon, which is making it much easier for package developers to have type safety, so there will be less of a room to make an error and assume that, hey, this you should handle this error. That we have an exception for this error, so it will end up with like a very good structured data sets that we will be looking into the Dart side, and we will have to handle. I think that's one way of looking at it. GNI gen and FFI gen and all the new stuff for related to calling native code, they always have a generator, and that generator, hopefully, I haven't tried them recently. Hopefully, they do manage to also bring all the exceptions from the native side, create an equivalent of them in Dart. I think at least GNI gen actually do that. I don't know about the one, the general one, FFI gen, but GNI gen actually does that, which is now I'm coming back to it. I think that's a good answer to, at least for Android.
okay, that's great. So someone is asking, how can you retrieve an error that being thrown from the isolate that is in charge of maybe playing music on the background?
Well, isolates are just they use the messaging mechanism. So you will have to send that as a message, and the message receiver is going to do it, or like the place where you handle those messages, you're going to decide based on the message. So the message is a good result or a bad result. In the end, it's just a message where you can decide what is it. But I don't think you can just try it or wrap it in a try catch and assume that it's gonna handle it, because it's running in a totally different zone, and it will probably not send or throw the error back at you. It will have to be sent as a message and handled differently. We have seen, like, for example, another example of handling errors, which is not through exceptions but through results. So if you have an exception or an error, you don't send the exception, or you don't call throw exception, but you send a result saying this was failed, and that's how you handle it. But uh, this is how I would handle it. Maybe there are different, better ways, especially for isolates, since they have been getting a lot of updates recently in the last year or so.
Okay. Okay. So there is a one more question, that can platform dispatcher dot instance dot on error and the flutter error dot on error report the duplicate errors as well?
Yes, that is pretty much this case here. If I go back to it, platform dispatcher, yeah. So platform dispatcher is actually gonna catch all the errors. So you might end up getting all the errors, but the platform dispatcher on error has a return type of boolean which says, do you want to send this error as well to the Flutter one? So if this error is Flutter one, do you want to send it to Flutter on error or not? So usually we return on error. We do whatever, login, printing, and all of that. But we also return true for this callback, platform dispatcher instance dot on error. We return true so that it doesn't end up being called on Flutter error as well.
Okay. So another thing that when you have a complex application, you are using the state management like a river pod or block or anything, and then that time how you can handle the error, the uh, specifically anything like you can mention here how to handle
I,
the error
I
through
think
that in architecture.
Architecture wise, I think provider is very simple, basic element. So at least if I'm talking about provider and not Riverpod, uh, it, you're just gonna handle errors the same. You're gonna handle them. For example, block is a little bit more involved, more complicated. So they have their way of modeling the data. So for example, when there is an error, they have a callback for when there is an error. So it actually is different. While with provider, for example, you're going to have to handle your errors the same way you handle them, as we have seen in this talk. You're just going to have to handle them normally. But for block, obviously they have a specific error handlers, but doesn't mean that they will be hiding some errors from you. It's just a way of them of encapsulating the errors, so that the block users have a unified way of handling all the errors related to the state management, which is actually really good. If you are in a big team, it makes sure that people are not handling the errors. This guy handling this error the different way to this one, because it's a large team, and nobody can keep an eye on all of the errors. So block is actually has a nice approach where you try to define, at least for the state errors, a good way of unifying all of those. I think I haven't tried Riverpod, so I wouldn't be able to know if they have something.
Okay. And how can I customize the error widget that appears when a build error occurs, but for only for the specific widget?
That one is this case. So if we take a look here, let me go back to the picture so I can explain it much better. So here, when I updated this UI for the error, I have updated it for literally everywhere. So whenever we get a red screen error or a gray error, screen of death in release mode, it's gonna change. It will be changed by this custom error. But how do we change it only for one widget? It is literally just a try catch exception in your build method, or create an error boundary widget that will have a custom child, obviously the child itself, and then a custom error builder, which is the specific widget, but wrap in like the child builder, wrap it inside the try catch, and anything that happens during that build method is going to be um, uh, is going to be catched, and that is when you build the error child, for example. But yeah, the other one is global, and it will change it everywhere, so you can customize it if needed.
So one more thing, I just want to ask here, because everyone is talking about AI, Rav, right? So people are using the build the application with the AI and all this stuff. So what is the role of AI in error handling as well?
Well, it definitely did a lot, at least to me. For example, I'm very lazy to create like error-friendly messages. So I know, for example, something went wrong, and whatever went wrong, how do I say that to the user, like as a final customer? It's very hard. So let me figure out a good example where I show that uh, definitely AI is probably being used more than it should be. Um, is a case where we show the message. So where is that? Yeah. So here, for example, we usually take whatever data as we get, for example, from the exception. The exception said failed to fetch the data, and it gives us error code for 401, whatever it is. But when we send that to the user, it's going to annoy them. So for me, at least, a really good use case for AI is like creating error messages that are user friendly and consistent. So I don't say in this page error failed to failed to authenticate, and in this page I say authentication failed. Obviously that's a copywriter job, but then that is what AI is here for, is to take that instead and replace it
Yeah.
with AI generated messages that are much better, and I don't have to wait for a copywriter to do it for me.
So because of about this topic of AI, right? The whatever you have explained here, the different types of error and how you can handle it. So are you giving feeding this data to AI and it will take care of all your code? Is it possible to do that? So
I mean, I don't think any of the AI products or LLM products out there are capable of taking a look at, for example, our large code base at work, because it's like really a lot of lines of code, and they will and AI start gonna hallucinate, and they will not know about all the errors. So that is where we have also the other option where I said centralized error handling.
yeah.
So if you have a file with all the exceptions, the kind of exceptions, or you have specific files per layer. For example, the if we're at the technical layer or like the lowest level layer, we have a list of exceptions, and then if we are at the let's say the data layer, we have a specific list of exceptions. Then it's just one file. I just feed it to the AI and say, give me a good message to show to the user if this is going to end up being shown to the user. So I think a good way to prepare for the future is that you definitely are going to use AI to help you with your error messages. So you better already go ahead and create a centralized place where you put the exceptions and you define the exceptions, so it can be easily manipulated by AI.
That's great. Okay. And do you want to suggest any packages or anything here so that it will easily people can handle their air? So, is there any packages they can look into that, or
Uh,
any package or any kind of thing that where the when you read the errors in the logs as well, there should be like a color scheme and other stuff like I can see. So maybe you can
yeah, yeah.
suggest to the viewers as well about such things.
There are a couple of packages. Like I think the one of the very popular ones is just Logger, like Loggger, which is a package that helps us with like colorizing the logs and all of that. I think Block also does that by default. I think Felix also has another package for login, but this one comes down to taste, which Logger is your favorite, but it does not matter. That is not what matters. What matters is that you're going to have to use one of the loggers instead of just basic print statements, because those you should reserve them only for quick and dirty fixes. But for heavy and production ready applications where the application is big enough, then having a logger is definitely going to help. Obviously, this is when we're talking about something already in the market and it's already making money and it's a real business. So keep using print if you're not making any money yet. So
That's great. That's great. So thank you so much, Ralph, bringing this amazing, important topic while you developing the apps, and thank you so much for the all the viewers who are attending right now live, watching us.
I
But
think
if
George is asking if we're going to be in Flutter London. Are we
yeah,
going to be in Flutter London? Yes. Are we? Yeah,
that's
we are.
great. That's great. So definitely, if you are not right now watching us, but you can watch afterwards as well. If you have any question, put it on our comment, and Ralph will definitely answer that questions. So we will passing all your comments to Ralph, and he can answer that question for you. So thank you so much, everyone. And this is the webinar series Code Magic has started. Please let us know if you want to cover any particular topic through this webinar series. Definitely let us know. And if you know any particular speaker as well who wants you to be on our platform, definitely let us know of that as well. So thank you so much. Thanks for your time, Rauf, and thanks for your the amazing
Thank
content.
you. Bye bye. Have a good evening.
Bye. Bye, everyone.